Thank you, Mr. Chair, and good afternoon, everyone. I'm Hiroyuki Ichijo. I'm very glad to participate in this kind of ITU meeting representing the WMO, World Meteorological Organization. Today, my presentation is to introduce WMO infrastructure, namely WMO information system, WIS in short, and Global Telecommunication System, GTS. As you may know, GTS is a truly operational system and existing system on a 24/7 basis. On the other hand, WIS is now at the pilot stage with several prototype systems. And according to the WMO strategic plan, WIS will enter the initial implementation phase early next year. We are now struggling to implement and coordinating the globally. So that today's presentation material includes such a kind of strategic issues. Yeah. First slides show the WIS concept, vision, and the features. Vision, overarching approach for solving data management problems, such as differences of data format and data policies, such a kind of problem. There are so many in every field. So our tackle point is to solve such a kind of problem. For all WMO and related international programs, not only the WMO, related, including our scope is including our other organization program, such as GEO, Global Group on Earth Observation, and other programs is our scope. And WIS will be a single coordinated global infrastructure for the collection and sharing the information. That's a vision. The key points of features, common standards, functions, and services for all. Second one is second one is real-time, supporting real-time and non-real-time information. The third one is interoperability through the online catalogs based on the metadata. Fourth one is seeking cost effectiveness and system compatibility. That's features. WIS services are categorized into three. First one is routine collection and dissemination for time critical and operational critical data and products. Second one is data discovery, access, and retrieval service. We call DAR service, in short. This mechanism is based on the request-reply technology, like an internet basis. Third one is a timely delivery service for subscribers. For example, scheduling, delivery, and any event-triggered delivery. Such a kind of requirements are a lot. So we implement such a kind of functionality. These are WIS services. This diagram shows the conceptual structure. WIS consists of a small number of GISCs, Global Information Service Centers. We expect less than 10. Dozens of DCPCs, data collection or production centers and hundreds of national centers, symbols NC, and also the many kinds of telecommunication networks. The core networks is we call the WIS core network. It's a closed private network, but a high performance network. Partly, the GTS take a role of WIS core network. And other networks, so many kinds of telecommunication means. For example, frame relay, MPLS, Internet VPN, satellite VSAT connectivity, and so on. WIS comprises three components. One is GTS, already exists. Second one is IGDDS. IGDDS stands for Integrated Global Data Dissemination Service. I explain the detail later. And the third one is DAR service. So the GTS part. GTS is, of course, one of the WIS component, and also the great successful component of WMO, World Weather Watch programs, so-called WWW. WWW combines observational system and telecommunication facility and data processing and forecasting systems. This picture shows such a kind of activity of WWW. It's a very popular diagram. GTS comprises 6 regional networks, region 1 to region 6, 6 regional networks, and a core network named MTN, main telecommunication network. The map shows the connectivity of MTN circuits. There are 18 MTN centers and 24 connectivity. It's a core network. And 2 closed networks cover that connectivity based on MPLS technology, multi-protocol level switching. It's a modernized network technology. Next is an example of regional network. My part, region 2, Asia. So mesh topology. Currently, there are 77 circuits in operation. And blue one shows the traditional legacy protocol net circuit. Red one shows the TCP/IP link. In 2001, the TCP/IP link is only 3 in Asia. Most of all was traditional protocols, X25 and asynchronous protocols, and such a kind of old-fashioned circuits. But we established a strategy, 2 strategies. One is the migration to TCP/IP base, and the second one is from the high-cost leased line circuit to cost-effective network. So we tackled such a strategy. This is the last August status. achievement rate of TCP/IP is 82%. Still remain the legacy protocol, but most of main circuit is already migrate to the TCP/IP link. And clouds basis, internet clouds and MPLS frame relay clouds cover the 61 circuits. So in my sense, good improvement, I think. But regrettably, 3 member countries are still isolated from GTS. That's Baghdad, Iraq, and Kabul, Afghanistan, and Thimphu, Bhutan. Yeah, not only the technical reason, but also the administrative reasons. But we continue to coordinate, establish such a link. But it's a very, very tough work. And so many kinds of data and products are exchanged over the GTS. The next 3 slides show the data availability. First one is SYNOP data coverage map. SYNOP, the 6-hourly surface observational data. Blue one shows a good reporting station. Data availability on the GTS is more than 90%, almost perfect. Their observational data is put on the GTS and circulated globally. Contrary, red point is a silent station. They observe the atmosphere, weather, and so on, but not put on the GTS, silent station. Why? The main reason is the technical problems, such as poor telecom infrastructure and lack of telecom facilities. It's a real world. So we try to improve the resolve such silent stations, but still remains a lot of silent stations. Next is SIP report. You can find SIP routes easily. Last year statistics, the number of average reporting from SIPs is about 3,000 a day. This monitoring period is last July 1st to 15th. The daily average is 2,765, almost 3,000 SIP report exchanged on the GTS. And the last one is TESAC report. TESAC means temperature, salinity, and current report from sea stations. Sea stations mean the buoy and voluntary observational big ships. Fortunately, we get a lot of such a kind of a TESAC report. This period averaged almost 1,500. It's a good number, I think. Next is the detail of IGDDS. IGDDS project is one of WMO space programs to provide efficient efficient circulate scheme on space-based observational data and products. The baseline is a collaboration of regional component for inter-regional exchange of satellite data. Each regional component includes a DCPC and assure the routine dissemination through the satellite broadcast that based on modernized technology, satellite digital video broadcast, DVB, yeah, and also cover the terrestrial dissemination through the internet and dedicated networks. It's IGDDS. It's currently partly in operation. And Asia, Europe, and the US is just this March started the inter-regional exchange of regional satellite data. And probably next year, Australia and other countries join such a regional network. And the IGDDS project will be completed within 2 years, I hope. And as a function, well, as a WIS component. There are so many satellites. These satellites are targets of IGDDS. As you know well, the monitoring climate and the weather remote sensing data is indispensable. Used to be we create the forecast only depend on the data, in situ data, observational data, land line, surface data, and upper temporal data. But currently, major data is satellite data, especially passive sensor data. So climate modeling is improved for last 10 years. Currently, we have good technology for assimilation of satellite data. Many kinds of different satellite data is possible to assimilate it and put on the model input. So very, very important data. And this is the collaboration with GEO, Group on Earth Observation. GEO represents a wide range of community belonging to 9 social benefit areas. Disaster, health, energy, and so on. And of course, that include weather, such as social benefit areas. Yeah. And GEO is promoting to build GEO system of systems, named GEOS, GOSS, system of systems. WIS is expected to be a core contributing component to GEOS. So we are now discussing about interoperability of GTS, DAR service, and IGDDS, and also GeoNetcast. GeoNetcast is the GEOS broadcast system, satellite broadcast system. We are discussing the technical standards and data management standards to get interoperability. Last two slides shows the activity in Japan Meteorological Agency, my office. JMA operates Tokyo Climate Center. Their main tasks are monitoring of climate system, greenhouse gases, and global warming prediction by climate model. Many outcomes published on the website and the WMO publications. And also, JMA promotes World Data Center for Greenhouse Gases. Their task is for gathering data and quality check, archiving data, creation of value-added products, and dissemination of data and products. And the outcome is published by WMO bulletins and their website. Please access, and there are so many information on the product outcomes. So I hope that you try to access this URL. Thank you.